Before we start this session to look into how to write chemical formulas of ionic compounds, compounds where cations and anions are attracted in order to create a formula unit, let's restate some of the generalizations that we worked on in a previous session. Um, in the previous session, we said we looked into and decided that metals lose valence electrons to make cations, and for metals in the representative groups, those are the groups that have the letter A associated with them. In those cases, the number of electrons that these metals would lose from the valence shell equals the group number, and that number of electrons equals the magnitude of the positive charge on those ions as well. Nonmetals, on the other hand, gain electrons in their valence shell, making anions. Now, this happens when nonmetallic elements are reacting with metallic elements. In other words, they are making ionic bonds. And for nonmetallic elements in the representative groups, which is pretty much all nonmetals, the number of electrons gained into the valence shells of these nonmetallic elements equals 8 minus the group number, which also equals the magnitude of the negative charge on these anions. Okay, so we'll use these generalizations in in this session and the next ones to figure out how to write the chemical formula of an ionic compound. Now, before we write the chemical formula of an ionic compound, I would like to reiterate a few sessions ago we talked about the information that we get from a chemical formula. Please remember that the chemical formula, number one, tells us the elements that combine chemically to make that compound. And number two, the subscripts in the chemical formula of an ionic compound gives us the lowest whole number ratio of cations to anions in one formula unit. Now that is going to be very important to remember as we go through this session. Now, when an ionic compound is created, when an ionic bond is made between two elements, electrons will be transferred from the valence shell of the metallic atom to the valence shell of the non-metallic atom. Because if you remember, it's the metallic atom that wants to donate its valence electrons in order to follow the octet rule, whereas the nonmetallic elements gain electrons into their valence shells in order to follow the octet rule. And that is basically what we will stick with while going through the discussions in this and the future sessions. Something that is very important to remember when you are trying to figure out the chemical formulas of these compounds, that the total number of electrons lost by the metallic atom must equal the total number of electrons gained by the non-metallic atoms. In other words, if a certain atom or atoms were to donate a total of 4 electrons, then the non-metallic atom or atoms should be accepting those 4 electrons. The transfer has to be even. And this is a very important idea to keep in mind. Basically, that leads us to the fact that total positive charge must equal the total negative charge, which means that the formula unit of an ionic compound will always be charge neutral overall. Just like an atom is charge neutral overall because the total number of protons equals the total number of electrons, in other words, the total positive equals the total negative, exactly the same way in this case, the entire formula unit of an ionic compound will be charge neutral overall because the total positive charge from the cation or ions equals total negative charge from anion or anions. So must keep that in mind. And it is because of this reason that we do not give the charges of the ions in the chemical formula of the compound. Now, this is what I mean when I say that we do not give charges in the chemical formula of the compound. Now, for example, sodium chloride is an ionic compound which is made from sodium at ion, sodium cation. If you remember from previous session, sodium cation will have a +1 charge, and chloride anion, chlorine, with a 1 minus charge, these two together come to make a compound. Now, when you're writing the ions, the charge is very important. It has to be given. But now when you're combining the two ions together to write the chemical formula in such a way that the total plus equals the total minus, we do not write the charge of each ion in that. In other words, if I were to write this as the chemical formula of the compound, that would not be correct. What will instead be correct is the same thing but without the charge. So when we write the chemical formula of the compound, the formula unit of the ionic compound, we do not write the charges of the ions that make that formula unit, because overall the formula unit does not have a net charge. So an ionic compound is formed when electrons are or transferred from a metallic atom to a non-metallic atom. So let's look at some of the highlights of a chemical formula. As we said, and this is the important one to remember, is that the subscripts in the chemical formula of an ionic compound give us the lowest whole number ratio of cations to anions. And I'll tell you why this is so important, and we'll keep it in mind when we write these. The overall charge of the formula unit must be 0. In other words, the total positive must be equal to the total negative. The chemical formula of the ionic compound, the cations are written before the anions. That's another rule for us to remember. No matter which elements are combining, the cation is always written first, followed by the anion in that formula unit. Okay, so let's try it out. Let's try to write a chemical formula between of a compound when lithium element and fluorine element chemically interact with each other. If you look at the periodic table, I hope you will notice that lithium is a metal, whereas fluorine is a non-metal. Lithium is in group 1A. So because it's a metal and in group 1A, when lithium donates an electron, the valence electron, it makes a lithium +1 cation. Fluorine is in group 7A, and since it's non-metallic, it gains an additional electron in its valence shell and makes a fluorine -1 anion. Now when these ions come together, when the lithium +1 cation and the fluorine -1 cation come together, they make a formula unit, they make a compound that has a chemical formula lithium LiF. In other words, we will need only one Li plus cation to balance out, to cancel out the charges from one fluorine anion. Please remember, the total plus must equal the total minus. In this case, the total plus in the formula unit of the compound, if you look at the cation portion, the total plus is +1 and the total minus in the anion side is -1, which cross out to give us 0. And that is the important part to remember, besides the fact that the cation is always written before the anion. Okay, let's try a few more, again going through the same process. Let's try and write a chemical formula between for a compound formed between oxygen element and sodium element. Now, one of these is a metal and the other is a non-metal. Oxygen is a non-metal, whereas sodium is a metallic element. Now, since sodium is a metal, it would like to donate electrons, as metals tend to do. So sodium is a non-metal, it wants to donate its valence electrons. How many valence electrons does it have? It's in group 1A of the periodic table. It's a main group element. Therefore, it donates one electron from its valence shell. Oxygen, on the other hand, since it's a non-metallic element and it's in group 6A, it's a representative element, it accepts or wants to accept two electrons in its valence shell. By doing so, the sodium atom will make an ion, sodium plus, and by accepting two electrons, the oxygen atom will make an ion, oxygen with a 2 negative charge. But here's the thing. Each sodium atom only wants to donate one electron, whereas each oxygen atom wants to accept two electrons. This basically means that we will need two sodium atoms to donate one valence electron each to one oxygen atom. In other words, we will need two sodium ions, cations, to combine with one oxygen anion to make this compound. So, just stating that same thing again, the sodium atom will donate one electron. Oxygen, on the other hand, wants to take two electrons, and therefore, in order to balance out the total positive and the total negative, the ratio of sodium ions to oxygen ions in this case must be 2:1. In other words, we need two sodium ions to combine with one oxygen ion, which means that the chemical formula of this compound is Na2O. That means that in one formula unit of this compound, there will be two sodium ions and one oxygen 2 minus ion, so that the total charge is 0. Please note that we do not write the charges of the ions in the chemical formula of the compound. Okay, let's try it again. This time, let's try and write the chemical formula of a compound formed between calcium and nitrogen. Remember, the procedure is exactly the same. We have to figure out first what are the ions that each one will make, and then once you know that, then you can put them together and make the chemical formula. So calcium is a metal. It's in group 2A, so it will donate two valence electrons to make a cation with a charge of 2 plus. Nitrogen, on the other hand, is a nonmetal in group 5A, therefore 8 minus 5, it accepts 3 electrons in its valence shell to give us an anion with 3 minus charge. And in order for us to put these two ions together, we will need a ratio of calcium to nitrogen ions to be 3:2. So the chemical formula for this compound is therefore Ca3N2. Now here's another way to account for the charges. When you see Ca3N2, when you see Ca3N2, again, mentally you can account for the charges by once again focusing on the total positive and the total negative. Now remember, each calcium ion has a charge of 2 plus, but then there are 3 of those, which means the total positive is 6 plus. Each nitrogen ion has a charge of 3 minus, but there are 2 of those. So the total negative charge is 6 minus, and therefore the total overall charge for the formula unit is 0. And that is the important part when you're putting the cations together with anions. Okay, here's another one. Let's try it out. Oxygen and aluminum. Please go through the same process. Aluminum is in group 3A. It's a metal, so loses 3 electrons from its valence shell, whereas oxygen is a non-metal in group 6A, therefore accepts 2 electrons in its valence shell, making an anion. Now, how do we put them together? What do you think? So, let's put them together. So, we are trying to put aluminum 3 plus together with oxygen 2 minus in a ratio such that overall charge is 0. There is a shortcut, and I will mention that here, and we'll do a couple of examples. This shortcut will work all the time, every time. So there's a shortcut. If you are not able to figure out the ratio on your own, you can adopt this shortcut by taking the magnitude of the plus charge and using that as the subscript for the anion, and taking the magnitude of the negative charge and using that as a subscript for the cation. If you were to do that, if you were to switch those numbers, then the chemical formula of this compound becomes Al2O3. A quick check will reveal whether or not this is correct. If there are two aluminum ions and each aluminum ion has a charge of 3 plus, what is the total magnitude of the positive charge? Exactly. Total positive charge will be 6 plus. Now, if there are three oxygen anions and each oxygen anion has a charge of 2 minus, what's the total minus charge? That is 6 minus, and those two cancel each other out to give us a neutral formula unit. So yes, our formula Al2O3 is correct. Please note that we are not writing the charges of the ions in the chemical formula of the compound. Okay, let's go through this again for the example where strontium is combining with sulfur. Strontium is an alkaline earth element Sr. It's in group 2A. It's a metal. Therefore, the charge on the ion it would make is 2 plus. Sulfur is a nonmetal in group 6A, just below oxygen, and therefore the charge on the ion it would make will be 2 minus. Let's use the shortcut to figure out the chemical formula. We said we take the magnitude of the plus charge, put it as a subscript for the anion, take the magnitude of the negative charge, put it as a subscript for the cation, and by doing so we get a chemical formula as Sr2S2. Please, cation goes before the anion. Now, is this correct though? Is this the final chemical formula? No, it's not. If you remember from previous slide, we said that the subscripts in the chemical formula must give the lowest whole number ratio. This is not the lowest ratio. So when you encounter a situation like this, all you need to do is reduce the subscripts down to the lowest whole number ratio, and that gives you the correct answer. Okay. So why don't we go through this list of elements combining with each other and write the corresponding chemical formulas of each of those compounds using the same strategy. Please go ahead and pause the video so that you are able to do this on your own. Hopefully you finished it, and these are the answers that you end up with. That is ALI3.